Lesson 9 is about finding length using what's called the distance formula, and this is basically an application of the Pythagorean theorem. So let's take a look at the distance formula here, and we'll be working with coordinate planes here, XY axes. In other words, it has several names, also called the Cartesian coordinate system. You may have heard it called that too. But the formula says that in a coordinate plane, the distance d between 2 points is given by that formula right there. And it looks like a long and complex formula, but when we think about it and compare it to the Pythagorean theorem, use that as an analogy, it does become easier to understand. We have d equals the difference in the x values, basically that squared, plus the difference in the y coordinates squared, and then take the square root of everything. So think about the Pythagorean theorem. We have c squared is equal to a squared plus b squared. If we take the square root of both sides, we come up with c is equal to the square root of a squared plus b squared. So we get the length of the hypotenuse. That's basically what the distance is. If we think about this as a right triangle, it's the length of the hypotenuse. Let's use Geometer Sketchpad to understand this a little bit more, and you can see I have that line segment there, AC, and let's say we wanted to figure out the distance of that, how long it is. Well, look, we can see our coordinates for point A. X is 2 and y is 4, and then we see our coordinates for point C. X is -8, y is 0. So look at that equation there that I have, xa minus xc. That's basically the same as x2 minus x1. We just have them labeled a little bit differently. So we take this value minus that one and square it. That always gives us a positive number when we square something if it's negative. And then we take ya, which is 4, minus yc. It really doesn't matter which order we do it because we're going to square it. That takes the negative out of it, and then we see that the answer there is 10.77. So that's how long that segment is. But maybe you're still confused on why this relates to the Pythagorean theorem. Well, maybe this will help. Look, I have a right triangle drawn there now, and hopefully you can see that that distance along the base of it, that is 10 units long, and then from A to B, that's 4 units long. So all we're doing here with the distance formula is when we find xa minus xc, we're finding a side, like side A. We're finding ya minus yc, we're finding side B of a right triangle. And so this works for any distance. We just set up a right triangle on it and we get those two sides. That's what xa minus xc is doing, is finding one of the sides. Ya minus yc is finding the other side. And look, there's our 3, 4, 5 triangle. We see that the answer there is 5 for the distance. So another formula to memorize, but if you understand that this formula here is an application of the Pythagorean theorem, then that helps you understand it better. You're not really learning anything new. It just looks a little bit different. It's just an application of what you learned in lesson 8. Let's go ahead and do some practice problems now. And in problem A, we want to find BC, that distance. That's just a number line. That's not a coordinate plane. It's basically a review of what you learned in lesson 2, where you just take the absolute value. You just can count. And if you started at C, you could say 1, 2, 3, 4. And so you could just say BC is equal to 4. We don't have any units that we're concerned with here, so we'll just write BC is equal to 4. Look at practice problem B. What is the distance between those points? -3, 2 and 5, 2. Well, think about this. The y values, those are both the same. So if we just thought about xy coordinate plane here, we'd go to the left 1, 2, 3 and up 1, 2, and then to the right we'd go 1, 2, 3, 4, 5 and up 2 again. That line there, it's just a horizontal line, so the distance between those points would just be 5 minus a -3, or 5 plus 3 is 8. So just something to notice on a problem like that. When you have the same, either both of the x coordinates are the same or both of the y coordinates are the same, you don't have to use the distance formula and spend a lot of time working with that. Just, it's the difference, the absolute value between those different coordinates. So in this case, the x values were the different ones, so we just take the absolute value between them and get the answer. Now, problem C, look at that one. What is the distance between point C and A on that diagram over there? Now we'll need to use our distance formula, but we can also simplify this a little bit, and instead of looking at those coordinates directly, we can just set up a triangle over there, and we can see that one side would be 3 units long, and then this side here is 6 units long. But let's go ahead and get some practice using the actual distance formula. We can use that example there to check our work. Let's figure out what coordinate C is at. It's located at -8, 0, and then coordinate A, it's at -2, -3. So let's go ahead and use those coordinates. Let's use C minus A as x2 minus x1. So our x coordinates, we would have -8 minus a -2, which would just be +2. That value squared plus our y coordinates, that would be 0 minus a -3, or +3 squared. So we get the square root of -8 plus 2, that'd be -6 squared is 36, plus 3 squared is 9. So we get the square root of 45. And so let's not convert that to decimal form. Let's just simplify that square root, and we know that we could do 9 times 5. Square root of 9 is 3. So we would just say 3 times the square root of 5. There's no units on this, so that would be our answer. 3 times the square root of 5. Now notice there, we can check our work using that triangle. We see this side of 3, 3 squared would be 9, and then that side of 6, 6 squared would be 36. So that helps us know that we did do the subtraction correctly. That is one of the harder parts on using the distance formula, is subtracting those coordinates the right way. A lot of times you'll end up subtracting x2 minus y1 or x2 minus y2 or something like that, and you get confused on that. But just keep up with your coordinates the right way on these, and you'll be fine. Set up that triangle on a coordinate system. If you're given a coordinate system, set that up, and that will simplify solving these problems also. Okay, practice problem D. We have a word problem here, and when we have word problems, we look for keywords. We try to figure out what they're asking about, and then we think of what tools we could use to solve the problem. Well, obviously this problem is going to deal with the distance formula, since that's what the lesson's about, but let's read it. It says, on a detailed drawing of a fighter jet, the tip of the nose is located at 0, 0, and the tip of the left wing is at -300, -240. If each unit represents 1 inch, what is the distance from the nose to the left wingtip in feet? So a key phrase there is, what is the distance? So we're trying to find the distance. Well, let's just write down that tool, the distance formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And we see we have coordinates here, so we can use those to help us solve this problem. And we don't have to draw anything. We don't have to know what the diagram of this fighter jet looks like. We can just substitute the coordinates in. And so we'll just go ahead and do that now. And for x2, we'll use that second set of values. So we'll say -300, and then -0, that would just equal -300. So we can say -300 squared plus y2, that would be -240, -0, that'd just be squared again. Now, we want to know the distance in feet here, and these units are in inches, these coordinate units, so -300 inches, -240 inches. We could go ahead and convert to feet right now if we wanted to, or we can wait till later. Either way, I'll just go ahead and do that now. And so we'll say D is equal to the square root of 300, just think about that, 300 inches. To convert that to feet, we'd need to say 1 foot per 12 inches, and there's our unit multiplier, we call those. So the inches units cancel, and we do 300 divided by 12, that would be 25 feet. So we actually end up with -25 squared plus the -240, 240 over 12, that'd be 20 feet. So hopefully you can do that one in your head. So you say -20 squared. So we end up with the distance equaling the square root of 625 plus 400, so we get the square root of 1025. Now you can go ahead and get a calculator out. They said round that to the nearest tenth, so you can use a calculator to figure out the square root of 1025. And so that would be 32.0 feet, rounded to one decimal place, to the nearest tenth place. So that's the distance from the nose, the tip of the nose, to the left wingtip is 32 feet. A way to check your work on problems like this is that the distance should always be bigger than either A or B, either of the other two sides that you have. So we had a 25-foot side and a 20-foot side, and so 32 is bigger than that. So that gives us confidence that we did the problem correctly. So like I mentioned in Lesson 8, it's good to have a page that you have all your formulas on. So think of those as your tools, and you use those tools, you apply them in new situations to solve new problems. So that formula page is like your toolbox. Put this tool, the distance formula, put that in your toolbox so you'll have that for easy reference. You can go back to it. Notice how I did this problem. I wrote that formula first, and that helps me think about what to substitute where. Okay, well that's all for Lesson 9.